Hello, welcome to Flipped. So today we are on metallic bonding, which is the chemical bond found in metals. And metal atoms, they lose electrons to form ions. So what do I mean? If I have a sodium atom here, it forms sodium ion, Na+, with an electron, okay? It's being donated. And the ions, which is Na+, arranged in orderly manner and held in fixed positions as such, okay? All these pluses are the Na pluses, which are the positive ions. In a giant lattice structure. So this whole thing is a giant lattice structure. And electrons lost. So these are the electrons lost. Okay, all this here are all these electrons lost. All the minus charges. Okay, will form a sea of delocalized electrons that surrounds positive ions. Because you see that every single atom gives out one electron. So if every single electron gives out every single atom just gives out one electron, it will form a lot of electrons, right? And that's what we call a sea of delocalized electrons. And this sea of delocalized electrons, they surround the positive atoms, like putting them in the middle. Okay, so there's electrostatic attraction between the positive and negative ions, and this is what we call a metallic bond. So between them, okay, the positive charge and the negative charge, there's this interaction, okay, and it's called a metallic bond. This is very, very strong and takes a lot of energy to break, okay, this orange interaction here. Okay, the sea of delocalized electrons can move from one end to the other end very quickly. So what do I mean? For example, if I were to apply electricity here at this end, okay, this electricity can be carried by all these negative charges here, okay, and they can move all the way to the other end, like this, like so. Okay, and that's why in the case of, for example, copper wire, electricity is able to be conducted from one end to the other. Okay, that's what I mean by the electrons can move from one end to the other quickly. And so you can conduct heat and electricity this way. So not only electricity, you can also conduct heat, which is, let me draw a fire here. Okay, this is heat, this is electricity. Can conduct this way. The other way works as well. Finally, the last property for metallic bonding is that it results in a high melting boiling point because the metallic bonds are very, very strong. Okay, so in metals, if you want to melt it or want to boil it, okay, which is almost impossible, you have to actually break this orange bond here that we are talking about. Okay, we have to break this bond here, which is very, very hard to break. And not just one, we have to break throughout the entire metallic metal. Okay, we have to break all the bonds between the plus and minus charges for them to actually melt and boil. So it requires very, very high energy to overcome these metallic bonds. Okay, we'll talk more about this chapter, okay, in chapter 9, which is a whole chapter dedicated to just metals. So for now, this will be sufficient in your understanding for metallic bonding.